You know, when you think of concrete, what comes to mind? Probably just a simple gray slab, right? Well, what if I told you that boring old slab is getting a seriously high-tech green makeover? We're going to dive into the recipe for the concrete of the future, and trust me, it's probably not what you're expecting.
So this brings up a massive question. Can we really take one of the most common materials on the entire planet and totally re-engineer it to be tougher and more sustainable at the same time? Well, all the latest research is pointing to a huge yes, and how we're doing it is absolutely fascinating.
Okay, so think about it like this. On one side, you've got your traditional concrete. Sure, it's strong if you squeeze it, but it's also really brittle. It cracks super easily, and let's be honest, it eats up a ton of natural resources. The goal? To turn it into something completely different. Sustainable Fiber Reinforced Concrete, or FRC for short. We're talking about a material that's tough, that resists cracking, and has a way smaller environmental footprint.
So how do we pull that off? The first key ingredient in our new recipe is fibers. Tiny little fibers. It sounds almost too simple, right? But just adding these to the mix completely changes the game. Okay, look at this number, 0.5%. I mean, that seems like nothing, right? It's a tiny fraction of the whole mix. But what if that tiny amount is the key to everything? Because when you add just that 0.5% of steel fibers, the concrete's whole personality just flips. It goes from being brittle to being incredibly tough. Instead of just cracking and falling apart, it actually holds together. It resists those big, catastrophic failures. And that means our structures are going to last longer, they'll need fewer repairs, and it's all thanks to that tiny 0.5%. But, you know, strength is only half the picture here. That word sustainable in the name, that's just as crucial. This whole thing isn't just about brute strength. It's about making concrete smarter and greener, and that means rethinking the core recipe.
And what I love about this is how common sense the approach to sustainability is. See, concrete is mostly just aggregates, sand and gravel. So instead of digging up new stuff all the time, why not just use recycled materials? And the research backs this up. It shows we can use crushed stone from old buildings and demolition sites and get pretty much the same performance. That is a huge win.
So let's break down this modern recipe, because it's so smart. First, you've got the steel fibers. They give it that strength and crack resistance, which means a longer lifespan. Then, the recycled aggregates. They're the bulk of the material, and using them means we don't have to mine as many natural resources. And finally, these things called superplasticizers. They help make the mix workable, which lets us use less water. And fun fact, less water actually makes the concrete stronger in the end. So every single ingredient is pulling double duty. It's there for performance and for sustainability. Okay, so we have our ingredients. But just like in baking, having the right stuff isn't enough. The technique is everything. How you mix it all together is just as important as what you put in. And believe me, it is incredibly easy to mess this up. Your first instinct might be, hey, more fibers equals more strength, right? Let's just dump a bunch in. Wrong. Do that, and the fibers just clump together into these useless balls, creating all these weak spots in the concrete. The mix becomes totally unworkable, you can't pour it, and the whole structure is basically compromised from the start. So how do we fix that clumping nightmare? Well, remember that third ingredient, the superplasticizers? This is where they become the hero of the story. Just think of them as a super high-tech lubricant for the mix. They make everything more fluid, which lets all those little fibers spread out nice and evenly instead of getting all tangled up. Honestly, they're the secret to making a strong, fiber-packed mix you can actually use.
And it's not just about chemicals. The physical mixing process itself really matters too. Researchers have figured out that you need very specific techniques. Like, the order you add the ingredients in matters a lot. And even pre-wetting the fibers before you add them can make a huge difference. It's all about fine-tuning the viscosity, the thickness of the mix, to get it absolutely perfect. All right, so we've got the right ingredients, we've got the right technique, but how does anyone know for sure that the final product is actually any good, that it's going to work? Well, that brings us to the final part, performance and testing.
See, success here isn't just one thing. It's a careful balance of a few key properties. You've got workability, which is basically, can you even pour this stuff? Then you have compressive and flexural strength. That's how it handles being squeezed or bent. And of course, durability, which is the big one. How does it hold up over time? A truly great mix has to nail all of these.
And this brings us right back to that crucial balancing act I mentioned. With FRC, there is always a trade-off. The more fibers you add to get that awesome strength, the stiffer the mix gets.
and the harder it is to work with. And that is exactly why the art of the mix, using those super plasticizers and the right techniques, is so unbelievably important. It lets you find that perfect sweet spot.
Of course, when you're building things like bridges or skyscrapers, you can't just guess. That's where official standards come into play. These rules demand super strict quality control on every single ingredient, from the cement all the way to the recycled aggregates, to make sure these new materials are totally reliable and, most importantly, safe.
But, and this is a big but, here's the new problem. The science is moving forward at an incredible pace. Like this quote says, our current standards are often playing catch-up with the newest innovations in these fiber-reinforced mixes. Basically, these new recipes are so cutting-edge that our rulebooks just haven't caught up yet.
And that leaves us with one last, really important question to think about. Right now, we are perfecting the recipe for the building materials of tomorrow, for a world that desperately needs to be stronger, more resilient, and way more sustainable. The big question is, are our rules, our industries, and even our mindsets ready for what's coming next?